What if our entire approach to digital trust is just fundamentally wrong? Today, we are diving into a really radical idea called the Deterministic State Machine, or DSM for short. It's a system that basically throws out the entire rulebook and asks this incredibly powerful question. What if the key to building trust isn't getting everyone to agree on everything?
So here's how we're going to break it down. First, we'll unpack the problems that DSM was built to solve. Then, we'll get into its core mechanics, and this is wild, a world that operates without a clock. We'll also see how it's designed to be hostile to spam right from the get-go. And finally, we'll put it head-to-head with blockchain and really explore the new philosophy of trust that it's proposing. Okay, so let's start at the very beginning. We're rethinking digital trust. And the first question we have to ask is, what are the hidden costs of forcing a global network to constantly, and I mean constantly, agree on everything? Yeah, this really gets to the heart of it, doesn't it? I mean, if you've ever used a blockchain, you know this feeling. You're waiting for confirmations, you're paying these insane fees, and sometimes the whole network just grinds to a halt. So what's the real root cause of all this frustration?
Well, it turns out that so many of these problems, they all come from this one single requirement: consensus. This is the big idea that every single computer in the network has to agree on a single shared history of events. But this constant need for agreement, it creates massive bottlenecks, it makes everything totally dependent on time, and it leads to what the source material calls global spam externalities. And in plain English, that just means one person's spam becomes everybody's problem, clogging up the entire system for all of us.
So, how in the world does DSM propose to fix this? Well, it does something that's pretty radical, to be honest. It gets rid of global agreement entirely. Instead, it builds a world based on purely bilateral, or, one-to-one relationships.
And this right here is the core idea. Instead of one massive public ledger that everyone shares, just imagine a huge web of private connections. Every single interaction between two people creates its own private history. Think of it like a cryptographically sealed receipt book that only the two of them share. This is exactly what makes the system self-verifying. The truth of a transaction isn't decided by a global vote. It's proven by the math right there on the receipt.
This comparison just makes the paradigm shift so incredibly clear. On one side, you've got the global town square of a blockchain, right, where everyone has to watch and validate everyone else's business. And on the other side, you have DSM's model of private conversations. And this is key. Finality is instant because the only people who need to agree are the two people actually in the transaction. That's it.
But wait a second, you're probably thinking, if everything is private, what stops someone from just spending the same money twice? This is where a really clever concept called the tripwire theorem comes into play. Think of it like this. Every single piece of money is cryptographically tied to its owner. So if you try to spend it twice, you end up creating two conflicting histories that just don't add up mathematically. It's kind of like trying to forge a signature in two different ways at the exact same time. The fraud becomes instantly and mathematically obvious to anyone you transact with. No public broadcast needed.
Okay, let's see how this design works in the real world with a concrete example. How do you fairly distribute tokens in a system that literally has no concept of time, no clock? The answer is a system called DJTE, which stands for Deterministic Joint-Triggered Emission.
This whole process is just incredibly elegant. The most important part is what's missing. There's no race, there's no competition, there are no timestamps. It all kicks off when a new user joins. That one single event triggers the whole thing. A random seed is generated, the system proves exactly how many people are eligible, and a winner is chosen and located. And it's all done through pure, verifiable mathematics. It's basically a perfect lottery that requires no clock whatsoever.
And that leads us to this core guarantee. Because the winner is chosen with perfect mathematical randomness from a provably complete list of participants, fairness isn't just some goal they're hoping to achieve, it's a mathematical certainty that's baked right into the code.
All right, let's tackle another huge challenge for any network: spam. Blockchains try to solve this with fee markets, right? If you want to send a transaction, you have to outbid everyone else for that block space. But remember, DSNT forbids time, which means it can't have a time-based fee market. So, how does it stop spam?
Well, the answer, once again, is to get rid of that global town square. On a blockchain, the mempool is like a single, chaotic, public mailbox for the entire world. Anybody can stuff anything in it. In DSM, you have a private, contact-gated inbox. You only get messages from people you've explicitly approved. So if someone starts spamming you, you just block them. And their noise never ever affects anyone else in the network.
And that contact gating is really just the first layer of defense.
The system also uses something called pre-commitment, which basically means that random junk data gets rejected before it's even processed. And for another layer of protection, there's this optional system of credit bundles. You can think of it like a prepaid postage system that limits how much anyone can send you, all without needing a clock or a competitive fee market.
Okay, we have covered a lot of ground. So let's pull all of this together and put DSM and traditional blockchains right next to each other, side by side.
This table really gets to the heart of the matter because it just lays out the fundamental trade-offs so clearly. See, DSM achieves its powerful guarantees by being incredibly strict. It absolutely forbids consensus, it forbids wall clock time, and in return for accepting those constraints, it gains instant finality and a natural, built-in resistance to the very problems that plague systems built on global agreement.
And that brings us to our final and maybe the most important section. Because beyond all the tech, DSM really represents a profound philosophical shift in how we even think about building trust in the first place. I just love this quote from the source material because it captures the essence of this shift perfectly. Instead of having to ask the network if something is true, which is really all consensus is, you interact with proof-carrying data. The data itself, the object, literally contains the mathematical proof of its own validity and its own history.
So, at the end of the day, what we're really doing here is changing the very source of truth. In most decentralized systems, truth is kind of a social construct. It's whatever the majority agrees that it is. But in DSM, truth becomes an objective, mathematical property of the data itself. It's something that can be verified by anyone, at any time, without needing to ask for anyone else's opinion.
And this brings us to the core question this technology leaves us with. For decades, we've pretty much just assumed that decentralized trust requires global agreement. The deterministic state machine proves that another path is actually possible, one built not on social consensus, but on self-contained mathematical proof. And that is a truly radical idea that forces all of us to rethink what the future of digital trust might really look like.